Welcome to Introductory Statistics 1. We are now on Unit 3, Conditional Probability, Independence, and Bayes Theorem. My name is Salas Kujobaji. In Unit 3, we'll start from Session 1. Session 1, Conditional Probability. Now, what do we aim to achieve at the end of this session? At the end of the session, we should be able to define conditional probability, explain conditional probability, and also calculate conditional probability in real life problems. Now let's get to know what conditional probability is. So when you ask, what is conditional probability? How will you define it? Well, conditional probability is defined as the likelihood of an event occurring based on the occurrence of a previous event or outcome. So we are finding a probability of a particular event based on the fact that another event has already occurred. Based on the condition that a particular event has already occurred, we are finding a particular event. Yeah, that's all about conditional probability. Now, so let's give a detailed example. I suppose A and B are any event of a sample space X, and B is not probability of B greater than 0. That's positive. Then the conditional probability of A, given that B has already occurred, is denoted by, so that is what is given. Probability of A, given that B has already occurred, is equal to probability of A intersection B, all on probability of B. Yes, earlier on we defined that probability of B should be greater than 0 or positive. You simply put in a fraction where you have the denominator being 0, then that it will not exist. So the denominator must exist and should be positive. That makes the probability valid or the equation valid. Now let's work on a concrete and get a concept more. Now let's pick example 1. Example 1. In a census, people living in a city were asked whether they could speak their local dialect. A resident of the city is selected at random. Let C be the event that the person speaks the local dialect, and let A the event that this person is an adult. Then we are giving probability of C equals 0.20, probability of A equals 0.17, and probability of A intersection C equal to 0.06. We have to find probability of A given C. We have to find probability of A given that C has already occurred, on the condition that C has already occurred. Now let's see the solution. Now the solution. So we have probability of A given C by way of the conditional probability formula. That will be equal to probability of A intersection C all over probability of C, as you can see. And from the example, we were given the probability of A intersection C to be 0.06 and probability of C to be 0.20. So dividing 0.06 by 0.20, you should have 0.3 as your answer. Very easy and straightforward, right? Let's try another one example. Example 2. Let's pay close attention to this example. In a high school class, 35% of students take Spanish as foreign language, 15 takes French, and 40 takes at least one of those languages. What is the probability that a randomly selected student takes French, given that the student takes Spanish? So you're going to find the probability of French, given that Spanish has already occurred. So you could guess the solution already? Yes, you should be able to. We know that the sample space X is 0. We should let X be the event of a person taking Spanish, that is P of X equal to 0.35. And we let F being French, that's 0.15 as we're given from the question. And we're also given probability of Spanish union French, that's S union F equal to 0.40. And we are to, what are we to find? Remember the question was demanding that we should find the probability of French given Spanish, that is probability of F given S. And the probability of F given X is equal to probability of X intersection F all over S. But in the question, we were not given probability of X intersection F. By the normal rule of a two-set problem, as underlined here, probability of X union F should be equal to probability of X plus probability of F minus probability of X intersection N. And bear in mind our interest in probability of X intersection N. So by way of filling in the values given with the various probabilities and by working out for probability of X intersection F, we will have 0.10. Now, coming to the actual question or the demand from the question. We have to find probability of f given x, and that is p of x translation f all over probability of x, and that is 0.10 divided by 0.35 as was given in the question as probability of s, and this should give us 2 on 7 when done properly. Very simple. I hope we can do similar exercise, right?